Hi,
Hey,
yeah. Hi, good evening, everyone. Welcome to Machine Learning Lagos, ML Lagos office hours. And and well, we are really pleased to have you guys here and enthusiasts here. Before we move forward, we'll go over the ground rules. And one of the first rules is to be respectful to everyone and also make the place welcoming and supportive to everyone. Engage actively via chat. If you have a question, you can raise up your hands. Keep the discussions focused on machine learning. Avoid spamming our chat. If not, we might remove you from the chat. Try and ask questions. Have fun. Please, next slide. So our agenda for today is, of course, we would have the session from Wesley, our GDE, and he'll also be answering some questions from us, and then we'll also hear a few things from us, a couple of us announcements from the community. Next slide, please. Next slide. Yeah. So a brief introduction about Wesley. Wesley is a machine learning engineer and data scientist. He is well adapted to creating production-ready machine learning systems that have had a lot of impactful solutions in the African market. He's a certified tech conference speaker. He shares his expertise through a lot of great talks, insightful talks. He writes articles on TensorFlow and Keras, and also shares his knowledge through many medium, like for example, joining this community call, answering to our plea. He's also a seasoned community organizer with vast experience in building Google developer communities from West Uganda. He's an active organizer in the GDG program and alumni of the GDSC program. He's currently a Google developer expert for AI. We're happy to have you here, Sir Wesley.
thank you, Michael.
Next slide. So I think we'll be going straight into the session.
Okay.
So Wesley, you can.
So I don't know what I'm going to be sharing with you guys today, honestly, but I'm just going to go through. These are about 5 slides, actually. So I'm just going to go through different approaches that are available to us in fine-tuning Gemma models. And then I'll go through a notebook real quick with one of those approaches, which is fine-tuning Gemma 3 models using the Gemma library. And then we'll get into the Q&A session. Right. So one Gemma model. I forgot to add an intro to what Gemma models are, but for those who are not familiar, Gemma models are open, lightweight models or a version of the Gemini models. So a lot of us may have heard about Gemini from Google, and then when we bring in Gemma, they're like, okay, so what is Gemma? So Gemma are just a light version of Gemini models. The difference is I think you guys talked about it in the last community event that you had, which I joined in shortly. Gemini are closed models, so you can only access them through the API. They are closed, they are proprietary models for Google. So developers are left with using them as they are. You cannot add anything. You cannot twist them. You cannot use them in any way that you would want to use them except with the API. Now, the Gemma models solve that problem. They are available to developers. You can fine tune them. You can use them as base models to build other foundational models. You can deploy them in ways that you may not even be able to deploy the Gemini models. So one of the ways is fine-tuning this model. So fine-tuning is simply getting a base model and adding in more context or more reasoning or more information in a domain or a task which that model lacks. So for instance, it could be mathematical reasoning, it could be translation, it could be question and answering parts, or it could be instructions, and you feel like, all right, this model does not, for instance, capture Nigerian pidgin. This model does not capture Nigerian street lingo or slang or Ugandan languages like Luganda. And so you need to provide it with more of that data and create your own version that is now, having that kind of context. So for us to do that, we go through quite a number of approaches. One, you could use the Hugging Face transformers with the LoRA technique. If you're going to do this, you need at least NVIDIA T4 GPU to do this kind of fine tuning with a little bit of about 16 GB RAM. You're able to fine tune Gemma 1B, 4B, 12B, and 27B, depending on your choice, or also on the data that you have, but also the resources, the compute resources. And it comes with a TLR and supervised fine-tuning from Hugging Face. We'll be able to see that in short while. And yeah, it supports the LoRA technique, which is easy for you to use in this context. I will be talking about that a little bit later. And if you must use a CPU, then you need about like 30 GB of memory to do that. The other technique is using the LoRa and Keras way. Still, you would need like a T4 GPU. You need a JAX backend. There are so many backends like PyTorch, TensorFlow, and JAX. But since you do not have enough resources, mostly you have like a T4 GPU, or maybe if you're lucky, if you can buy it, you may get an A100 GPU. So you want to use the JAX backend because it is very versatile, it is very fast, and resource efficient. And then with Keras, we use the Gemma Causal LM as the preferred architecture for us to be able to fine tune these models. With LoRa, you're able to reduce, if for instance you choose like the 2 billion or 3 billion Gemma version, you can be able to reduce that up to around 2.9 million parameters, which makes it easy for you to train because now you're no longer dealing with the 2.6 billion or let's say 11.8 billion parameters. You reduce them down to around 2.9 million to run on the T4 GPU. And you can always choose a very low rank, like 4 or 8 or even 16 if you have the resources. And if you're fine tuning, you can choose to use the full precision, or you can use to choose like mixed precision, whichever works for you. But if you're running an inference, like for instance, you want to test out the model if it is good at mathematical reasoning, if it's good at vision tasks, like like identifying things in images or describing what is taking place in videos, then you may want to use versus like mixed precision to be able to handle that. More of this will be more explained in the QA, but also in the netbook. So that's why I'm just rushing through this. The other way is for you to use the distributed fine tuning, still with Keras. Now, with distributed fine tuning, we mostly want to use TPUs because then they give us the best strategy for you to distribute the training across multiple TPUs. For instance, you will see if you're using Colab, you will always find that you have a V2 TPU. If you're using Kaggle, you will find that you have a V3. If you go to Google Cloud, you will also find a V3 with 8 cores. Now, if you have 8 cores, that means you can distribute that training to all those 8 cores to make the training, the fine-tuning more efficient for you. Which is unlike if you are dealing with GPUs or CPUs, you may not be able to achieve that distributed strategy. Yes, you can, but it's usually not as efficient if you are dealing with TPUs. And also because each core that you may have will come with 16 GB each. So imagine 16 GB multiplied by 8. So you have quite enough RAM for you to do this. And if you must, you can also use a single NVIDIA GPU, which is again available. Run a JAX backend and do parameter efficient training. So, but most importantly is this. So the Gemma library is it's a library from the Gemma team to make fine-tuning Gemma models much more easy. So the other strategies are from the broader Google teams and from other teams. So for instance, outside of Google, we have Ansloth. So if you want to fine-tune Gemma models, you could use Ansloth. It is one of the libraries available to you, but it's outside of the Google teams. So within the Google teams, we have the distributed, we have the Hugging Face transformers, we have the LoRA with Keras, and then now the Gemma library. The Gemma library goes hand in hand with the Cauldron library, and we'll be able to see why the Cauldron library comes in. And it is purely JAX. So having understood that large language models are heavy to run, they are resource intensive, the only way to survive this, to fine-tune a model like Gemma 3B, 3, 1B, or 4B, you need a good machine, but we don't have those machines. So you get JAX, which is more resource efficient, and you use it. I'll give you an example. One of the large language models that you guys are using that was fine-tuned using JAX is Grok from Twitter or X, however you call it. It uses a JAX backend, which makes it very, very easy to run without so much resources, because at that time, Twitter didn't have those fancy data centers or GPUs to do that training. And you can run on GPUs. So JAX are typically GPUs. You do not need a TPU to do this. A single A100 GPU is enough to do this. And then this supports also multiple pipelines for data. So your data can be from GitHub, it can be on Kaggle datasets, it can be on Hugging Face datasets, and so on and so forth. So this makes it much, much easy for you to do that training. So I'm going to go through the notebook here. So let me see if I can connect this. I'm out of resources. So I hope that this is able to run within the time that I have. Just a little bit. Okay, so I have about like 1 hour of an A100 GPU. So if you're going to run this on your own, a T4 GPU is really enough. If you're going to use the distributed technique, a V2 TPU is enough. But for this particular class, I'm just going to use A100 to make it much very fast for me. So install the Gemma library. It's just simple Gemma. So I'll let that run to do the installation. It's a very lightweight library, so shouldn't take a lot of time. And then most important is the most important part is now being able to import the operating system library. But this is the part where we get the Cloudron library KD and also get the Gemma library. Now, this is important because one, we get into the operating system and force it or override what is common with JAX. So JAX is made in a way that it does not utilize an entire GPU. It is not made to do that. So if you're going to fine tune a model, you want to override that default setting. Okay, you override it and make sure that you utilize 100% of the GPU, because you don't know how long, for instance, your model is going to be training. You don't know the resources that you need to train the model, so you override that default setting by ensuring that you use 100% of your GPU. Sorry, I need to run this fast. So once you've done the overriding, then that becomes pretty easy. So it means the training can stretch up to the entire GPU as you have it. Then you can create a tokenizer from any of the available data pipelines. So this is me tokenizing a very simple sentence. This is like an example sentence, and this is like the tokens for that particular sentence. Now, this is where KD comes into play. One, you're able to create a very simple data structure that one contains your data set. So for this part, I just went on the internet and picked out this data set here from the machine translation datasets that are available on TensorFlow datasets. So I can change this to, the task is to be able to translate English to French. You could do that for any other language that is available. Unfortunately, Pidgin is not available. Yoruba, Hausa, then the Ugandan languages like Luganda, they are not available. So I just did French. Split into train, shuffle through, create a very small batch size of about like 8, and then do the sequencing to sequencing task. This is for you to create your model, the inputs, the targets, and then the loss mask. And then you're able to, for instance, select the field of the dataset that you want to use, which is from the source itself. And then the batch would have one, what is the input, what are you targeting, and what is the loss mask. And then, of course, you want to do some bit of padding. So you can pad to about 200 parameters as the maximum length. and then truncate anything that is beyond that. So you do that and make that a bit true. So with this very simple function from Cloudrun, you're able to get your data a bit ready. Now, once the data is ready, you can then go into a very simple decoding example. So for instance, you want to be able to check what is coming from the batch that you've given to the model. Try to inspect it and see what it gives you, whether it is kind of like correctly following the Gemma dialog format. So this, we can see whether one, when you start the user, for instance, we say, the user can say, as much as Democrats would like to see this happen, blah, 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 then the user ends, then the model starts, because it's in a way of a conversation or a chat. So the model starts and says, oh, converts that into French and tells you, well, my French is a little bit rusty. Now, instead of specifying, the parts when, for instance, you look at other strategies or approaches, you have to create a string and then provide the name of the model you want to fine tune. Here, it's already available as much or less like a class or a function. So you just change this to Gemma 3 7B, Gemma 327B. So right here, I'm using the Gemma 4B model. And then you want to also be able to specify the loss function that you're going to use. So one thing that you would have to probably note is you already have your data set, the model, and all the losses connected, okay? And so you want to be able to register all those kind of strings, the batch, what the dataset will output, or the output of the dataset. You want to be able to predict, or that is, so you specify the preds, which noted as preds here, which will be the output of the model itself. And then you want to be able to provide some parameters, like for instance, the weight decay loss, or you want to monitor parameters in normal metrics. Again, this may be a little bit, advanced or not easy to follow through, but bear with me. I'll be able to answer some of those questions. Now, for the trainer, you want to be able to provide a temporary checkpoint that, where you're going to save your fine-tuned model. So you create that temporary checkpoint, and then you have, of course, the training data set. You have the model, which you already got as Gemma 3 4B, and then you load the checkpoints for the model that you've selected. So, of course, we selected 3 4B, the instruction model. So IT is for instructions. Then specify the number of training steps. So I could reduce this to about 100, not to make this, a little bit, to make it a little bit faster. And then, so I'll do the training part. So we now do start the training part. So in instance, the steps that I've just gone through to start, training the model are so easy or very short compared to every other approach. These are about, I don't know, like 6, 7 cells, and I'm already fine-tuning my model. And so this is going to take just a little bit of time. But once it's done, then you can save the model parameters. You can activate the checking point from the trainer, and then you start evaluating the model. So we'll be able to evaluate the model and see whether it is now a little bit better than it was when it did this. All right, so this was before we trained the model. We want to see how it performs, and now we are fine-tuning it, so we'll be able to evaluate it a little bit down here. So as this runs, there are some things that I've mentioned that could be a little bit, hard to understand, or a little bit advanced, maybe first time hearing them. So I will be taking in now the questions as this goes on, if that makes sense, or if that makes it easy for us to have this session. So the questions, they would come in. This will continue training, and we'll see when it stops.
Yeah, thank you so much, Wesley. I think the questions, I don't know, if are you there? You could share your screen, or I could just go ahead.
Yeah, I'm here. I can share my screen.
Okay.
Do I have to stop sharing mine and then maybe I'll come to it?
Yes, please.
Okay.
Our first question is it's about like fine-tuning process. So how do you decide between full fine-tuning versus parameter efficient fine-tuning like LoRA?
Okay. How do you make that kind of a decision? It depends. It depends. One of the most important things that define what architectures, what techniques we are going to use when we are fine-tuning models is the dataset. What is the kind of dataset that we have? It will define the architecture that you will use. It will define the techniques that you're going to use. For instance, if you're going to decide between full fine-tuning and PEFT, question is how large or how big is your dataset? But also, even if it is big, the question is what is its quality? So you want a really good quality dataset without a lot of noise, without a lot of missing data or imbalanced. So the dataset really determines a lot how you decide between one of the two. Secondly, you want to understand what is the task. What are you trying to achieve in fine-tuning the model? Do you, for instance, want to change? Do you want to change the behavior of the model, the already pre-existing model, the way it responds to questions or queries, the way it generates data? Do you want to change that? Then you will either go for a full fine-tuning of the entire model, or you will just do parameter efficient fine-tuning. Do you want to go deeper and do like something called deep knowledge integration? Okay, maybe the model lacks in some of the domains or tasks, like for instance mathematical reasoning. Maybe the model lacks. All right, so if you want the model to get better on mathematical reasoning, you choose maybe that I will do a full fine-tuning so that everything is covered, or you could choose any of the reasons why you want to. For PFT, PFT1, you want to look at, for instance, like I've said, datasets. If you have limited data, or you lack compute engine, compute units. So for instance, you don't have an A100 GPU, you have a T4 GPU, which is limited. So you're not going to do a full fine-tuning. You'll have to turn it down. If you, for instance, you want to retain the base model knowledge. So for instance, Gemma comes out of Gemini, right? Now, it means it already has the entire knowledge of Gemini. Okay. Now, you have your task where you want this model to be able to translate, for instance, English, normal English to Pidgin, or Pidgin to normal English, or Yoruba to English. That's what you want to do. Now, in most cases, you don't want to have the model forget, or you don't want to erase what the model already knows. Okay, so you want to retain the base model knowledge, and that's when you will choose parameter efficient fine tuning with LoRA. Okay, in other cases, when you want to do what we call things like modular training, you just want to train on a very specific task, or you want to train on a small domain separately from the rest, then you will choose PEFT with LoRA. I hope that kind of like answers how you arrive at this decision.
Yeah, thank you so much, Wesley. I mean, I have a question about that, but I'll keep that until next session. Please, so the next question is how do you handle overfitting during fine-tuning, especially on small domain specific data sets? So, or even data set like, yeah, small domain data set like let's say Nigerian languages that we know that okay, or African languages to put in large scale that we don't even have sufficient data. So how are we going to handle overfitting in these small domain specific data sets?
Well, handling how you handle overfitting in fine tuning is it's not different from how we've been doing it with our normal CNN or RN models. It's not any different. The same techniques that we've been using are the same things that you do. So for instance, when you're writing your neural network and you're going to train it on maybe classification, we use things like early stopping. So you can still do that. You can do early stopping. You can do validation loss monitoring. So you can monitor, for instance, the validation loss when the model is training. So you can do these things when you're fine tuning. You can, when you're building your model architecture, you can add things like dropout. You can add a dropout layer to ensure that it reduces on what the model gets to learn during the fine-tuning process. Even things like what like weight decaying. You can decay weight because as the model is learning in the neural networks or transformer, for this case of large language models, there are a lot of weights. Weights keep changing, and some get bigger, some get smaller. So you want to do some bit of weight decay in that. If you have very small data sets, for instance, you want to do things like data augmentation. For instance, you have a very, very small data on a low resource language in Africa, like our small communities. So you don't have a lot of text on them. You can paraphrase that text that you have. You can get just one sentence, you paraphrase it into 5 other sentences, and then you give that to the model to avoid overfitting. And then other things like regularization. You can do an adapter tuning if you want to really do that. So there are ways, the same things that we do on a daily basis. It's the same way we can do it here.
Yeah, thank you so much. We also have another question for you. Does the Gemma library allow quantization or pruning post fine tuning? So can we quantize a model or prune the model?
What I'm sure of is quantization is there. You can do that. You can
Yeah.
you can do, for instance, You can change to 4-bit quantization. You can do what? Let me see. You can do int 8 quantization, or yeah, you can do int 8 and 4-bit. That I'm sure of, because for 4-bit, if you use the LoRA approach, you achieve the 4-bit quantization using a library called bits and bytes. So standalone, you do not have, the Gemma library does not have that capability as standalone. But when you apply and use the bits and bytes library, you can achieve the 4-bit quantization. Yeah, so, but for the part of pruning, I don't think so. It's not supported within the Gemma library. So if you want to achieve pruning, which library can you use? Trying to remember. I think you could use a library called what? Optimum? Optimum? Yes. You could use Optimum if you want to achieve pruning within the Gemma library. It's not natively, like it's not supported. That's what I know from the documentation. It's not supported.
Okay.
But also there's also called,
but
also there's something called, it's relatively new, or it is something that we don't do or like use every day. There is something called post-training quantization. So like you quantize the model after the training, not before training it. So some people want to quantize the model because you don't have a lot of resources. So you want to quantize it and then you train. Some people who have the resources can train the model as it is, then they quantize it after the training, especially now when you want to deploy, for instance. So when you want to deploy, a very efficient, lightweight model. So some people do it. Yeah, you say it's common, but yeah, a lot of people want to do it before training. So yeah, I hope that answers the
right.
question.
Yeah, sure. I mean, there are comments. So next question is, I'm sorry, we have a lot of questions, but what
It's
are the
okay.
best
I have
real
the
world
time.
scenarios to? Okay, what are the best real world scenarios to fine tune Gemma 3, or do you have any example from the industry? Sure.
Yeah, we are having those scenarios every day. While they didn't use the Gemma model, but I'll give you that example because it's one of the national achievements you guys have in Nigeria, the Yan GPT. All right, so the Yan GPT, they used a model called small LM. That's what they fine-tuned. And so, yeah, even that same approach, that same scenario that Sahid used with Yan GPT, he can use it with Gemma. So you can fine-tune Gemma for translation, for text-to-speech, recognition. You can, it's being used to support bots. So you find companies or organizations in finance, in healthcare, in security, in education. They want these bots. They want to build bots. And then those bots should be familiar with their context. Like, for instance, how is health done in Nigeria? How is health done at a certain hospital? How is finance done in the Nigerian market, in the Ugandan market? So you get that data, you fine-tune Gemma, and then you deploy a bot where, if I'm going to, for instance, if I asked Gemma right now about taxation in Nigeria, it will give me general general answers to what it thinks or has been trained on, but it will lack the context. So I have to fine tune it with data from the revenue authority in Nigeria or the revenue authority in Uganda. In the legal fraternity, you could give it all the legal cases that have been handled in Nigeria or Uganda or Kenya, and you fine tune it. Recommendation, yes, we've built recommendation systems on our popular e-commerce platforms, Jumia, Amazon, and blah blah, on Spotify, Apple Music, YouTube, and all that. But you could still use Gemma 3 to fine tune it with what people buy or consume, and then you have a very better recommendation system. So yeah, there are so many real world scenarios where you need to fine tune Gemma 3, and you can use any of that. In education, you can just go to your former school, you can go to Unilag and get their entire curriculum for the last 5-10 years and fine-tune Gemma 3 on it, and then deploy that model back on Unilag. And students will be able to understand what their lecturers teach, at Unilag, which is more different from how our lecturers teach at versus Makerere University in Uganda. So yeah, there are quite a number of those scenarios.
Yeah, thank you so much. So next question is, how do we evaluate model performance within the Gemma library? Are there like built-in tools, or do we have any custom metrics that you feel like should be added, like in your own opinion?
Well, so the thing is, the Gemma library is a new library, just like the Gemma models are new models. So it is not all round. There are so many things that need to be added. Some of these things are being worked on behind the scenes. And so we will see improvements. But for now, Gemma library doesn't really support a lot of model evaluation as it. You have to use for instance, Hugging Faces trainer for you to do that, to get in the inbuilt metrics. Like, for instance, you want to get the accuracy, you want to get the F1 score and stuff like that. You will not get them directly from Gemma library. However, you can integrate Hugging Faces trainer and to give you those metrics. You could also, if you want to, for instance, if you have fine-tuned the instruction models, the IT models, then you want, for instance, to evaluate chat quality. Okay, you're chatting with the model, you fine-tuned, and you want to see whether it is good enough for you to deploy it. You could do a human A/B testing, get humans to sit down and evaluate the model, do some bit of like a baseline. Or you could use the available external benchmarks or evaluation criteria. Like most common one is MT bench. It's one of the benchmarks that people have to achieve. There is the truthful QA. So if you want to evaluate chat quality, then you want to use the truthful QA to evaluate how does the model answer the questions that are being asked. But Gemma does not have these tools inbuilt as for now. So it is our task as the ML community to actually contribute these things to the model, because it's an open library. So yeah, you can do that.
All right, that's cool. That's cool. I think the next question is about community stuff. So are there any community notebooks or open source projects using Gemma 3 that you feel should contribute to, like maybe learners or people that just love open source they can contribute to or learn from, so that
Yeah.
our chats can.
Yeah, sure. So while the library is new, it's not that old. There have been a lot of efforts to support the community, and so there are so many available notebooks. I think I'll share a link to the official Gemma GitHub account, so that you can go through some of those things and find the notebooks with some of the scenarios and use cases that you wanted to know. You may find them there. Two, the Hugging Face community is one of the most supportive communities that I've seen in AI, and especially around large language models. So Hugging Face has a number of documents, notebooks, datasets, everything around Gemma. They do have everything that they've been on this journey from Gemma 1, Gemma 2, and now Gemma 3, and they've been instrumental. So you can go to Hugging Face and find anything. You can go to Kaggle and just search. You can just type it right now and search something around Gemma. So yeah, there are quite a number of notebooks and projects. So one of the projects is Gemma Chat. There's a project called Gemma Chat. You can use that. It's fine-tuned on chats. So like the name suggests, Gemma Chat. It's to be used in chat use cases like bots and stuff like that. So you can search that project and contribute to it if you want to. There's another project I'm trying to remember. I think I came across it a few weeks back on GitHub. So LoRA being one of the most used techniques in fine-tuning, these guys have an entire repository on how you can do fine-tuning with Gemma. They call it what? I know it has the word LoRA in it. I'm just trying to remember the name. But if when I remember it, I will share with Ifan and he can share with the entire community. Yeah. So yeah.
Yeah.
Any other questions?
No problems. Yeah, there are a lot of questions. So do you think is fine-tuning still the best way to personalize models, or are there techniques like adapters or prompt tuning which are more feature proof? Are they more feature proof? So what do you think are the best ways to personalize models? Is it via adapters or prompt tuning? Like moving forward.
Okay. What can I say on that? Is fine-tuning still the best way to personalize models, or are techniques like adapters, prompt tuning more future-proof? Well, it depends. It depends. How it depends is so for things like, for instance, adapters, if you want to do adapter tuning or you want to do prompt tuning, they are currently more popular, especially among developers and small businesses, for one reason. We do not have the compute that is needed to do a full fine-tuning. So we have to settle for adapter tuning or prompt tuning. Okay. 2, we do not have the data. So for instance, me, when I wake up and I feel like, oh, I want to fine-tune Gemma, right? It's because I want to do a specific thing, a specific task, or a specific domain. So I will do modular training, like just for that specific, because I have data of a specific task or domain, I'm not going to go for a full fine-tuning. I will do LoRA, I will do adapters, I will do a prompt tuning because of that. So when you are faced with that kind of scenario, you're going to use those techniques. But full fine-tuning itself is also still useful. It is also still used, especially when you have the compute unit, you're dealing with very big domains. So for instance, in finance is a very huge domain with a lot of data available. When you go to traffic or transport, there's a lot of data involved. So you leave some of those big domains or large domains to the big guys who can do full fine tuning. If you're just a single developer or a group of developers without the resources, you go for adapter tuning. So it depends on what you want. But we are increasingly in a world where the big guys will build the models, all right? Google will do the Gemma, Facebook will do Llama and all that, right? They have the resources. Now, the rest of us in the world, we don't have the resources as they do. So we will go for the techniques that favor us. So it is more, to answer your question, it's going to be that these techniques are more future proof. Okay, they are more future proof than fine tuning, which is reserved for the big guys. So if you want to do you want to keep like for instance, look at OpenAI, look at Google. How long do they take to release a model? Like, let's say we now have Gemini 2.5, right? How long do you think we are going to get Gemini 3 or Gemini 3.5? We now have Gemma 3, right? But you can imagine how many versions of Gemma 3 that people have fine-tuned and put out. So in terms of doing continuous learning, because Google has to wait for quite a long time, gather enough data and resources, then fine-tune Gemini and release a new version. But for you today, you will get Gemma 3, then in a week, you've gathered new customer data, right? And then you fine-tune Gemma, it gets to learn. Then after 1 month, you have new customer data, then you fine-tune again, it learns. So for you, you are able to do that continuous learning and training of the model. Plus, these models are supported on even the tiniest devices. So you have all this on device use compared to the very big models. So the future, if you want future proof, then yeah, these techniques are more important and will be in use for quite a long time. So the full fine tuning will be reserved for the big guys. I hope that kind of like answers it, makes sense anyway.
Yes, yeah, very extensively. So I think that's all the questions for now. We do have some questions from the chat, but I don't know if you want to show us your work. Is it complete?
Oh yeah, it's just finished. Let me share this thing. I checked it and it was okay, so yeah, so you can see that the training is now 100%. So and this is because I like I said, I had reduced the training steps to 100. If it was still 300, that would have been quite some training. So now I can do some little bit of evaluation. So let's try to evaluate the model. I want to evaluate it with the same sentence that it had here. So we want to see if there is any little bit of difference, because right here, it was not yet fine-tuned. Now it's been fine-tuned on a data set. So I want to be able to see if there is a difference. I'm going to change this and put that, and then run and see. So let's see what it does, if it's able to translate that and maybe see if the translation is as good as it should be. So as it does that, no, okay. So the Google Meet chat section doesn't have questions unless maybe they're on YouTube, which I'm not seeing for now.
Questions on YouTube. Should I go?
Okay.
Yeah,
You
someone
could
asked.
pick one or two. You
Yeah,
could pick
Jordan.
one or two and
Yeah, Jordan is asking, could you please highlight more about deploying a fine-tuned Gemma model? I intend to serve a fine-tuned Gemma model for use inside of an Android app. So it's asking how to fine-tune a Gemma model and how it's going to be used in an Android application.
okay. So one, you can see the response. You can see this response from this compared to the response that we had here, right? So it's a
Yes.
little bit different, which means the model at least has now more context than before. Now, once you've done this, right? Once you've done this, you can push your checkpoint for your new Gemma model, because now this becomes like a new version of Gemma 3. So you push your Gemma 3 model on places like Hugging Face or Keras Hub, right? Once you've pushed them to the Hugging Face or Keras Hub, you can then run an inference of that model in an Android application. Too bad is I'm not be able to cover what running the inference is, but I could share a link to an example that can demonstrate that. I've had that session on how you can run an inference in an Android app with a community this side, but that's the approach. You push your checkpoints to like Hugging Face or Keras Hub, then run an inference within your Android app using a framework called MediaPipe. So yeah, so we use MediaPipe to run models on device. So for Jordan, I think that's the task. He can learn on how to use MediaPipe to run inferences of models on Android. Build your app. Could be a chat app, could be recommendation app. You fine-tuned your model, push it to Hugging Face, then come down in your code and run an inference, so that when users are using your mobile app, they're actually interacting with your fine-tuned model that is somewhere on Hugging Face or Keras Hub. So,
All right,
yeah,
thanks. All right, thank you so much for that.
Yeah.
There's another question by Emiratus. He's saying that is Gemma only integrated with Keras? What of touch? I'm thinking he's saying PyTouch.
No, so so the thing is, so the first approach that I shared for Hugging Face transformers and LoRA, that approach is actually mostly done in PyTorch. So you can use PyTorch, you can use JAX. I've already mentioned JAX multiple times. You can use TensorFlow, you can use Keras. It all depends on which one you if you're familiar with or you're efficient with. It doesn't have to be Keras. It can be JAX. Like for instance, the notebook that I've shared, it has nothing. It has no single code about Keras. Nothing. It's not there. But there's an entire example or approach where you can use Keras. And then there's another approach, like when you're using the Hugging Face transformers, where you can use PyTorch. And then there is another approach. For instance, when you're doing distributed fine tuning, right? When you're doing distributed fine tuning on a TPU, then you're going to use TensorFlow. The reason is PyTorch and JAX are not TPU friendly. I mean, TP, it's in the name. These are tensor processing units. So they're going to locally, or the native framework for them is TensorFlow. If you try to run JAX, you will get into errors because JAX is not built for a TPU. So Gemma is free for any framework. It is free for any technique that you want to use. It's not just Keras. No, you can use anything.
All
I
right.
hope that answers him.
Yes.
Okay. Okay.
There's some questions. I have some questions here. So one question is, how does momentum? I know that momentum is also a way to fine tune, to help in the process of fine tuning or helping in overcoming overfitting. So how does momentum help in that?
Honestly, I'm not really familiar with that. I would say I've not done that. I've not interacted with that kind of use case or where I need to use momentum. Honestly, yeah, I can't really.
And also,
answer
I don't know if you.
Yes.
No problem.
Okay.
Yeah, I don't know. Have you used quantized models before? Like, what would you say is the difference? Should people be doing more quantization? That is post-training quantization. So does quantization affect the model's inference results? Do you think?
No.
I don't know if
No.
you have had experience.
I have been quantizing models from as early as when we're doing TensorFlow Lite models, because one, you do, for instance, a classification model, right? With images, you want to do multi-class classification. You have this very huge data set of images, like 50,000 images. You train your model. That model is going to come out very, very heavy. You would release a TensorFlow Lite model that is about like 1 GB, or that is about 500 MBs. That is a very heavy model. Quantize it down, cut down on its weights, right? Because quantization is just typically reducing the weights of the model. So quantize it, do like, for instance, post-training quantization, reduce the model to about like 100 MB and then deploy it on your device. So it is not something that you're going to it's not something that you're going to avoid if you're going to do, because you will fine-tune a model, and then when you release the model and you want to serve it on your device, do you know how huge it could be? It will be very huge. So you have to quantize it. There's no question about that. They're called large language models. They're classification models with images. They're huge models. So you either quantize before or you do post quantization, but you're not going to avoid it, unless maybe you're doing these small machine learning models that when you release it, it's like 200 KB. You don't need to quantize that one. But also the quantization does not affect the model performance, not really. If you've trained your model really well, you know that the model is not underfitting or it's not overfitting. It achieved the best fit. Quantize it, then deploy it. And then, yeah.
Nice. Thank you. I think that's all our questions for now.
Okay.
I think I'll stop sharing so that we can.
All right.
Yeah. So that brings us to the end of our office hours. We're really happy to have you on the call, Mr. Wesley. We look forward to more collaboration, more future collaboration, and we thank you so much for your great expertise and knowledge you have shared with us so far. And yeah, we just want to say big thank you. Really appreciate you.
Thank you for
So
having me and for hosting me. Yeah, I look forward to more interactions with the ML community in Lagos.
yeah, thank you. So you can follow us on, if you are listening via YouTube, you can follow us on X, ML in Lagos, LinkedIn, Machine Learning Lagos. Just search for us. Also, we have an upcoming session, which is our technical session. So April's technical session is happening at the end of this month, 30th of April. So it's exploring prompt engineering and RAG with Google AI tools. So please register at bit.ly/ML Lagos Tech Session. Next, we have it's the same time, 6 p.m. Just follow us on our socials and you have more updates. The next information we have for you is our build with AI Gemini Spring 2025. I mean, I'm excited for this. I'm looking forward to many projects that are coming out from this. So stay tuned for future updates on this, and yeah, just join our community and you have more information. The next one is let me check. So this is just this is our flyer for the Build with AI session. So we have like a physical event that's happening on the 3rd of May 2025. So it's, if you want to get tickets to this event, please join the community and you are going to get it. I can assure you. So please join in and you're going to get tickets to this event. So once you do that, just drop in good comments on why you want to join this session and we'll look into it. Next slide, please. Yeah, thank you so much. And we really like your feedback on how you enjoyed the office hours, how we can improve. We definitely want to improve, definitely want to get better. So please drop your feedback at bit.ly/ML Lagos feedback. And we're really looking forward to hearing from you. Thank you again, Mr. Wesley, for joining us. Really appreciate, and do have a nice evening, everyone. Thank you.